Today, we're going to talk about Euclid's algorithm. This is the algorithm found out by Euclid. He's an ancient Greece's mathematician, I would say. So the algorithm basically finds out the GCD, the greatest common divisor. You know what a greatest common divisor is? GCD, right? So let's think about the GCD of the two numbers, 76 and 52. So 76 is, what is it? 4 times, let's say, 19, right? And then 52 is 4 times 13. So GCD 76 and 52. The most greatest common factor is actually 4. So that's 4. Okay. The Euclid's algorithm is really simple and it's really fast. So that's really important in computer science. It's actually used in cryptography. So it turns out finding, GCD is kind of very important in actual RSA algorithm. It's kind of interesting. But anyway, so how does the Euclid's algorithm work? It's simply this. Keep taking the remainder of the 2 until arriving at 0. And then I'll put the non-zero number. Let me elaborate that first. So let's think about 76 and 52. So let's take the remainder. So what is the remainder? So that means the remainder is 24. So I will just say A and B and then R to number A, B, and then remainder. And then in the iteration, you dump the biggest number, just take these 2 numbers in the next iteration, and you just take the remainder again. So in this case, 48 would be the thing. So the remainder is actually 4. Okay. And then take this, 24 and 4 at this moment. Remainder is 0. Okay. And then go there and then 4 and 0. Oh, so we actually reach a 0. And then this is the output, GCD. Okay. So that's a simple algorithm and it's really fast in a sense that the number actually gets exponentially, smaller. So even if it is a large number, you can actually, the computer can find the GCD very fast. Okay. So how would you program that? Well, at least what you see is keep taking the remainder. So that means we're going to repeat the remainder algorithm, remainder operation again and again. So it's really good. It's the really good place to use while. So until arriving 0. So that means while not 0. So basically, while was not 0. Well, in a sense, B is not 0, right? While B is not 0, you keep doing this remainder algorithm, and then if B is 0, exit the loop, and then you're gonna output what? A. So that's what we're gonna talk about. So let's code up. Okay, so let's think about GCD.C. Okay, so include std IC210.h into main, and then let's say f put s, give 2 numbers, okay, and then send that out. So from that, and then you have to read 2 numbers, right? So, and a is read num from a standard in, and then another integer, you read it. Okay. And then what? While b is not 0, we keep taking the remainder, right? That's what we're talking about. So while b is not 0, if b is 0, time to exit the while loop, what do? Take the remainder. So I'll just create another variable r, and then what do? To the remainder. So a% b, the remainder is stored in r. Okay, so this is r. So 76 and 52, and then 24. And then in the next iteration, what do you have to do? Well, you have to change the value of the variable. Now, what's contained in b becomes the a's value, and then r becomes b's value, right? So that means what? So the value a is changed to be what b contains, and then b becomes now r. Okay. And then what do we have to output? Output is a, right? So let's write standard out, and then after that, and then \n and standard out. Okay. GCD.c. Good. So give two numbers. What is the two number? 76 and 52. Good. So let's try out other numbers. 7, 9. Good. 6 and 8. Good. Big numbers. And this is 2. Anyway, so it works. So that's GCD algorithm.